and welcome back to Teacher Gimble's channel. Make sure to like and subscribe if you want more videos like this, and put in the comments any lessons that you want to see, and I'll make sure to post them soon. Today we're looking at Illustrative Math, Algebra 1, Unit 3, Lesson 1, Practice. Let's get started. Problem 1. This two-way table shows the result of asking students if they prefer to have gym class in the morning or in the afternoon. I first situate by myself by looking at the table. So I see we have grade 6, 15 students prefer the morning, and 15 students prefer to have gym class in the afternoon. The total of grade 6 students is 23. I notice at grade 8, 18 prefer the morning, 21 prefer the afternoon, 39 is the total number of grade 8 students. Grade 10, I see that 12 prefer the morning, 26 prefer the afternoon, and the total of grade 10 students are 38. Then I notice this column says total. What this tells me is that 45 students total like the morning, 55 students total preferred the afternoon, and there are 100 students total in the survey. By situating myself with the table first, it makes it easier to answer the questions. How many students participated in the survey? Well, we've already identified 100. How many students in grade 8 prefer to have gym in the morning? I'm going to go to my grade 8 column, and I see 18 students prefer it in the morning. How many grade 10 students participated in the survey? I go to my grade 10 row, and the total number of students who participated in the survey is 38. Finally, how many students prefer to have gym in the afternoon? So I'm looking at my afternoon column. I want my total number of students, which is 55. 55 students prefer to have gym in the afternoon. Pause this video here and re-watch if you have any questions about this problem. Let's go ahead to problem 2. A random sample of adults are asked about their preferences for a first dinner date with somebody. Complete the two-way table so it has the characteristics listed. 122 people responded in the survey. 50 of the people who said they ordered dessert said they also prefer to split the check. 68 people prefer splitting the check, and 56 people prefer to skip dessert rather than ordering one. So let's look at our table and see what's there before we go ahead and put the numbers where they belong. So this column over here will people who order dessert. This number will refer to people who like dessert and split the check. This one will refer to the people who order dessert and want one person to pay. This one refers to people who do not want dessert, and the ones who split the check, and ones who prefer one person to pay. So 50 of the people who said they ordered dessert said they also prefer to split the check. So let's go ahead and say 50 who ordered dessert prefer to split the check. That's going to go right here. We know we have a total number of 68 people who prefer splitting the check. I'm going to put my 68 over here for the total column above. If 50 prefer to split the check, we can say 50 minus 68 minus 50 is 18. So the 850 who order dessert and 18 do not. Now we have 56 people prefer to skip dessert rather than ordering one. So we have 56 people who prefer to skip dessert. Well, we know 18 of them split the check. So let's go ahead and do a little bit of subtraction to identify how many people don't prefer to split the check, which gets us with 38. Finally, we know that there are 122 people in the survey. Well, 50 of them split the check and order dessert. 18 of them split the check, do not order the dessert, and 38 of them have no dessert and one person pays. If we add that all up, we get 106 people. We know there's 122 people in the survey, so we need to figure out how many are left. We do a little bit of subtraction. I carry the 1, and there are 16 people left. So 16 people order dessert and one person pays. These types of questions are a little bit like a puzzle. Go ahead and try to do it yourself if you had any trouble, and see if you can get the same answers that I did. Feel free to pause and rewatch this video, or post in the comments if you have any questions. Let's go on to the next one. Problem number 3. Students in the 7th, 8th, and 9th grade were asked whether they prefer to write in pen or pencil. I definitely prefer pen. 40 students prefer to write in pen. 60 students prefer to write in pencil. Creative values that could represent the number of students in 7th, 8th, and 9th grade that responded to the survey. So, we know that we have a total of 100 students. So, let's do some values. Let's say of 7th graders, there were 30. Of 8th graders, there were 25, which is 55. And then of 9th graders, we had 45. I did some mental math there to make sure that the total added up to 100 students, just like it described in the problem. Of my 7th graders, let's split that up. So, even you can see, it makes the most sense for me to make a two-way table as I'm thinking through this question, because there's just a lot of data. I decided my total 7th graders was 30. My total 8th graders would be 25. And my total 9th graders would be 45. So let's say 20 of them preferred pen. That means 10 would have to prefer pencil. If 20 8th graders preferred pen, 5 would prefer pencil. And if 20 9th graders preferred pen, then 25 of them would prefer pencil, because I know totals have to add up to each of my total number of students over there. All right. The probability that 7th, 8th, and 9th graders all had the exact same number of students prefer pencil is pretty low, but we just need our data to match the example in the problem. Now our last question. A recent study observed the number of bike riders aged 0 to 20 that wear helmets. Always wear a helmet. The results are represented in the table. So take a second and look at the table on your own. We're going to make an observation based on a data value that is not in the table. Explain your reasoning. So I'm going to go ahead and look at the table and think about this. Well, I don't see any totals, so I could say there are more people who wear helmets than do not. More people overall wear helmets than do not. Because I notice that all of these numbers tend to be bigger except for 16 and 20-year-olds. But these numbers, actually, nope, my observation was wrong. Because 11 to 14-year-olds, fewer people wear helmets, and 16 to 20-year-olds, fewer people wear helmets. So let's fix that. I could say more 0 to 10-year-olds wear helmets than 11 to 20-year-olds, which makes sense because as people get older, they might wear helmets a little bit less. And that is an observation that I could make. But notice, sometimes we make observations and make mistakes. It's always important to check our work and make sure that we're looking over those mistakes. If you have any questions, please put them in the comments below. And as always, if you like this video and subscribe, you will get more content with the lessons as I post them. And if you put in the comments any lesson that you want, go ahead and do that, and I'll make sure that one